Now we have the third video in our sequence. This one is on real numbers and the number line. You're also going to see a little bit about properties, although only a little bit because we're going to get more into that in the upcoming videos.
All right, everybody, let's go ahead and continue this and roll on to Chapter 1, Section 3. Reminder, find me on YouTube at SV Math Teach. All right, let's begin. Chapter 1-3 talks about real numbers and the number line. And it begins by talking about sets. Now, if you've never heard of sets or a set, I drew a fictional basketball team, as you can tell, with 1, 2, 3, 4, 5, 6, 8 different players, one that's a bit taller than the others. And a set is essentially a group of items. They could be people, they could be colors, they can be, in our case, numbers or variables. You could call a set all the integers, or you could call a set all of the odd numbers, or you could call a set all numbers that I've ever said out loud. A set could be just about anything. Sets are generally recorded with these little mustaches on either side. I'm going to say B for basketball, and the set B contains, now I'm going to jump back down here to the word element. Each of these items would be considered an element. Each piece goes in, so they're like the ingredients. And I'll separate the elements with a comma. So this set B of basketball players contains the elements, element 1, 2, 3, 4, 5, 6, 7, 8. They could have names. They might get E1s, E2s, E3s, and so on. And then a subset is, if you would look at this original set of values, you might have basketball players that start. If you're not familiar with basketball, you need 5 players to begin a game. So what I'll do is I'll choose a subset, which is a subgroup of these, and I'll choose maybe this person, this person, this person, this person, and the tall person as my starting basketball players. And I'll separate those elements with commas, and now I have an example of a set, which are all the kids that play basketball, a subset, which is these people that I choose to start the game, the best 5 players, and the elements are the items inside. Now, you can apply that to a variety of different things. We're studying the real numbers, and real numbers are made up of 2 giant groups of numbers: rational numbers, which we're going to discuss in a moment, and irrational numbers. Now, before we get into what they are, let me show you a slightly larger version of the same thing. When I break real numbers down and I talk about rational versus irrational, find my pen, let's begin with what rational is. A rational number is any number that can be made with an integer on the top and the bottom of a fraction. And that's it. It comes from the word ratio. So if you can make a fraction or a ratio with 2 integers, then you have a number like a rational number. So for example, 3 over 25 is a rational number because it's made up of a ratio or a fraction with 2 integers. Now, when we get down to integers like a 5 or a -2, you might wonder how those are rational. They're rational because I can make them into 5 over 1, or if I had a little more space, -2 over 1. And I could make those into rational numbers again. As I get down a little bit more complex, inside of the integer set, so if the reals are the set, rational is a subset of this. Integers are a subset of both of these because it's a smaller grouping of these. Whole numbers are a subset of each of the ones above it. Whole numbers exclude the negatives. So they might start at 0 or 2 or 1004. Those are all examples of whole numbers. And again, I can make those into ratios like I did for the integers. And the natural numbers actually are exactly the same as the whole numbers, except, well, I should do this. I should take this out because the only thing that's really special about a whole number, and I should probably take this one out now that I think about it, is that this outside stuff is what makes integers special compared to whole numbers. Whole numbers are 0s and 1s and 4s and 1007s, and those 1s and 4s and 1007s are natural numbers. So if I do this a little bit more correctly, all of my positive integers are right here. Sorry, that was my dog. My 0s are what change natural numbers into whole numbers. From whole numbers to integers, I add negatives, like -4 and -1002. And then to get outside of that loop, you have to have a fraction or something like a fraction that can be made into a fraction. Irrationals are on the other side are square roots that are not perfect squares, cube roots that are not perfect cubes. For example, pi is an example of an irrational number. pi divided by 3 is an example of an irrational number. So there are a variety of different irrational numbers out there. Rationals can also be decimals. 2.3 is a good example. 2.4 repeating is a good example. Whereas over here, irrationals can be decimals, but they might be 2.459102. They would repeat forever, but they have no pattern to them. They're called non-repeating. They're called repeating. Oh, I'll try it one more time. Non-repeating, that's the pattern. Non-terminating, that means it never ends. So non-repeating, non-terminating decimals, that would be irrational. One more time. Non-repeating, non-terminating decimals, those would be irrational. Now let me get back to real numbers, because once you have that nailed down, and you probably have seen that in the past, we go back to this slide, and I'm going to show you one more piece. There are times when you're going to be asked to estimate real numbers, which is why the number line comes into play. You may be given something like estimate the square root of 24 without using a calculator. In other words, this is approximately how much. Well, the idea here is this. The square root of 24 is between the square root of 16, which equals 4, and the square root of 25, which equals 5. So the square root of 24 is kind of smack dab there in between them, but it's much closer to 5 than it is to 4. So without getting into a whole lesson that you probably did last year, we're going to estimate that our square root of 24 is approximately 4.9. All right, and that's a fairly good estimate. That gets us close. That would help us if we were on a number line. Let's say this is 3, this is 4, this is 5, and we needed to label that location. We might draw an arrow and say that that arrow represents approximately the square root of 24. Using a number line like this one will also help you to order other fractions. It could help you to order other decimals and so on. Oftentimes these questions will ask you to order numbers from least to greatest, and you'll find yourself changing fractions into decimals, leaving decimals the same, and then estimating square and cube roots. With that said, good luck. A reminder, if you need to reach me, SB Math Teach is the way to find me, and you can comment online about each of these videos. Good luck.